Alright, this is for my regular Algebra 2 classes. I'm going to run back through some examples. I'm just going to use odds off the worksheet 6.8b just to do a few more, help you guys out since I'm not here today. This is number 3 on your worksheet, so you guys are going to be doing evens. I'm going to work a few odds for you. One issue here, you're trying to solve for x on all of these problems, is that you see that x is in two different places. And those terms that we have, the x in, ax and cx, they're not like terms because a and c are different letters. So what do? On your handout from last week we said if you've got your variable in more than one term, that first you would want to get those terms on the same side of the equation. So I'm going to subtract cx from both sides of the equal sign. Okay, and then now with all these letters, they don't look like terms to you know, if you had like an 8x minus 5x, we'd just say 3x. What we're going to do here, because x is in both, it's a common factor, we're going to factor it out. And by factoring it out, it's going to create a parenthesis factor. So when I do that, I get a minus c left on the inside. Okay, so we really had this big quantity here, ax minus cx. I'm taking the x out. When you take the x out, it's going to be gone from each of those terms. You're going to have a minus c as a quantity. And now that you've done that, x has only been written once now in the problem. It's a factor. The other factor is the a minus c. We've got times here, right? So all we're going to do is divide both sides of the equation by the quantity a minus c. And when you do that, the binomial a minus c cancels out, leaving x alone, and you get your answer x equals b over the quantity a minus c. So when you see your variable in two terms, get those terms on the same side, factor it out. When you factor it out, you're left with a parenthesis factor. You divide both sides by the parenthesis, you're done. Okay, let's take a look at another example. Let's see, how about number 9? So that was number 3. Let's scroll down here, we'll take a look at number 9. Number 9, I've got a times the quantity 2x minus b, okay, and then equals c times the quantity dx minus 1. Now if you look at your handout again from last week, okay, move it up there. One of the scenarios said, what if your variable's stuck in a parenthesis? Alright, well here we've got x in the parenthesis, and not only that, it's in two terms. Alright, under the scenario where we said if x is stuck in a parenthesis, we said really there were two options. Option 1 is get the parenthesis alone, and that would be like this, dividing by a and canceling the a's out. Okay, the problem here is you're starting to make fractions, dividing both sides by a, and you still have another x. So the other option is the better option here. We don't want to get the parenthesis alone because that's not the only place we've got x. Okay, the other option was to distribute to get rid of the parenthesis, and that's the better option here. And we actually have to distribute twice because we still have two parentheses. So we're going to distribute. We're going to avoid making any fractions at this point. So I'm going to have, I'll keep my letters in alphabetical order. 2 times a times x, and then minus a times b equals here c times d times x, and then minus c times 1 is just c. Okay, again, this is number 9. Now, at this point, I'm solving for x. X is in two places. What are we going to do? Just like the last example, we're going to get those two terms on the same side of the equation. So I'm going to leave the 2ax over here. I'm going to subtract, okay, the c dx from both sides. So I'm going to cancel the c dx out from the right. I'm going to have minus c dx on the left. And then I only want the x terms on the left, so that negative ab, I'm going to cancel it out by adding ab to both sides. So I end up with a positive ab on the right. Now that I've got both terms with the x and only the terms with the x on the left, that's when I factor out that common factor. Both of these terms, right, really have this quantity of 2ax minus c dx. They both have an x. So we're going to factor the x out. When you do that, you're left with 2a minus cd. Okay, and then on the other side we have ab minus c. Now we can divide both sides of the equation by the parenthesis factor, right? That's multiplication right there, x times the quantity. So we're going to divide both sides by the quantity, 2a minus cd. Remember, we just treat a whole parenthesis just like a single value. It's just some number. We're going to divide both sides by that number, whatever 2a minus CD is, and there you go, x is alone. That would be your answer for x. Okay, let's take a look at least one more here real quick. I'm going to try not to let this video be too long. Okay, let's see. Actually, I'm just going to erase the whole thing. Start fresh. Okay, let's look down at, how about number 13 is another odd problem. That would be a good one to do. We've got a over b, I'm still solving for x, equals x over c, and then plus d. Alright, one of the scenarios just says, in general, you have fractions. Okay, sometimes your variable might even be in a denominator of a fraction, which is, you know, something that we don't want to deal with. Okay, what we're going to do is we're going to first, I would just say in general, let's just get rid of fractions, clear fractions. So that's when you think about what would be your common denominator. You know, d right now is d over 1. We're not going to get common denominators, but think about if you got common denominators, what would be your least common denominator between those fractions? And hopefully you can figure out that it would be b times c. Okay? And when you figure that out, you're going to multiply now every numerator by b times c. We're allowed to do this because it's an equation. I don't have to change the denominators as long as I multiply all the numerators. After doing that, we go through and cancel. Okay? The bcx over c, you can cancel the c's. In the first fraction, you can cancel the b's. In the last fraction, you already have a denominator of 1. Nothing's going to reduce. But you now have the equation AC equals bx plus bcd. You have no more fractions. This is pretty nice in that x is in only one term. So I would go ahead and subtract the bcd from both sides. Let's just get rid of the non-x term from the right, since the x term is over there. And then you can divide both sides by b to get x alone. Here you can divide the entire quantity, the entire left side, by b, or you could go through and divide each term by b one at a time. If you divide each term by b, your answer would look a little different, but this is a good answer. Somebody else might have written AC over b and then minus BCD over b and done it one term at a time. And if they did that, you should then just go ahead and reduce your b's if you're writing it that way. And then they would leave their answer as AC over b minus just a CD. Okay, both of those answers are good answers for x. So I probably would have left it like that, but it doesn't matter. Okay, and one last one. Okay, the last one is, what if you come across a problem like number 17? In 17, you are now solving for y. Instead of x, it says y plus 3 over x plus 6 equals a negative 2 over 3. Now, a problem like this, we just want you to go, okay, there are fractions. I can multiply through by what would be the least common denominator. That works, but the shortcut is, if you recognize that it's one fraction, okay, on the left, and only one fraction on the right side of the equal sign, it's just a proportion. And you can cross multiply. The diagonal products are equal. So the product of 3 and y plus 3 is equal to the product of negative 2 and x plus 6. So you can set those diagonal products equal. And from here, we have a couple options. We're trying to solve for y. Y is only right here in the problem, the only place it shows up. I can get the parenthesis alone by dividing both sides by 3, or I could just distribute. I would probably distribute here because I've got, you know, parentheses in a couple places, and I would just go ahead and get rid of all the parentheses, I think, first. Seems like it'd be a little bit nicer option. And then from here, I'll collect the non-y terms on the right, so I'll take away 9 from both sides. Okay, so I get 3y equals a negative 2x minus 21. And then lastly here, I would go ahead and divide by 3 and get the y term alone. And again, I can divide the entire quantity on the right by 3 and make one big fraction, or I could go through and divide each term by 3. So you can do it like that, in which case you'd basically have your answer right there, or I could have written it out this way. Negative 2x over 3, and then minus 21 over 3, which would be 7, if you're just dividing each term individually. So that looks good. If you left it like that, that would be okay as well.